You're standing at the edge of nothing. Above you, below you, in every direction. Darkness, stretching farther than light, has traveled in the entire history of existence. And yet you're warm. You're breathing. Right now, you're sitting somewhere safe, scrolling on a screen, completely unaware of where you actually are. For your whole life, you've been told the universe is everything. No walls, no edge, no outside. Just space, expanding forever, in every direction, with nothing beyond it. But what if that's wrong? What if there is an edge? And you're already on the wrong side of it. Here's the part that should bother you. When physicists take the total mass of everything we can observe, every star, every galaxy, every speck of dust in the cosmos, and plug that number into the exact same formula used to calculate the size of a black hole, the numbers line up. Not close. Almost exact. The radius a black hole would need to contain that much mass is roughly the radius of the observable universe. Estimates put the mass of the observable universe at somewhere around 10 to the power of 53 kilograms. Run that number through the Schwarzschild radius formula, the same formula astronomers use to calculate the size of the event horizon around a real black hole, and the answer lands close to the actual radius of the universe we live in. Two completely unrelated calculations, arriving at the same number. So is it possible that everything, galaxies, stars, your house, your bed, you, is sitting inside the event horizon of a black hole? That's what I want to show you. Most people picture a black hole as a violent little point somewhere out in space, ripping apart anything that gets close, a cosmic drain. Matter goes in, gets crushed, gone forever. But that picture only describes the outside. Nobody has ever described what it looks like from the inside, because nothing that crosses that boundary has ever come back to tell us. And that silence is exactly where some physicists started asking a different question. In 1972, physicists Raj Pathria and I.J. Good, working independently, noticed something strange. Take the Big Bang seriously. An unimaginably dense point that suddenly expanded. And it looks almost identical, mathematically, to the inside of a black hole. Both begin at a singularity. Both involve space curving in on itself so completely that nothing inside can ever get back out. Fast forward to 2010. Physicist Nikodem Poplawski, working at Indiana University, published a model built on a version of general relativity that includes something called torsion. In his version, when matter collapses into a black hole, it doesn't crush down to an infinitely small point. It reaches a maximum density and bounces. On the other side of that bounce, space expands. Rapidly. Outward. In every direction. From the inside, that bounce would look exactly like a Big Bang. Here's the key. In Poplawski's model, every black hole could be the seed of a brand new universe on the far side of its horizon, which means our universe. The one you're living in right now could be the other side of a black hole sitting in a universe we will never, ever see. Now, some of you are thinking, that's just one physicist's model. Fair question. So here's the part that gets me. Back in 1997, theoretical physicist Lee Smolin proposed something similar, which he called cosmological natural selection. His idea: universes that produce more black holes effectively reproduce more, passing down physical constants, like the strength of gravity, that happen to be good at making black holes. Generation after generation, universes evolve. Like a family tree, except the children are entire cosmoses. And there's another piece of this that comes from a completely different direction. In the 1990s, physicists Gerard Hooft and Leonard Susskind developed something called the holographic principle. The basic claim is bizarre. All the information contained inside a volume of space, a black hole, for example, can be fully described by information stored on its outer surface, like a 2D shadow that contains everything about the 3D thing inside it. In 1997, Juan Maldacena built a working mathematical model showing exactly how a universe's worth of physics could play out on its boundary, with everything inside just being the projection. Put plainly, a black hole's entire interior might just be a kind of readout of information sitting on its horizon, which raises an uncomfortable question. If that's true for a black hole, why wouldn't it be true for us? So what would it actually feel like to be inside a black hole without knowing it? Picture this. You cross the event horizon. From the outside, this is the point of no return. But from the inside, you wouldn't feel a thing. No flash, no wall, no warning sign, no sudden crushing pressure, no siren going off in the sky. Space just continues, the same as it did a second ago. Stars still burn. Light still travels. Nothing announces what just happened. A little anticlimactic, honestly. Here's where it gets strange. Once you're inside, the geometry of space and time rearranges itself. The direction that used to mean toward the center stops being a direction in space and becomes a direction in time. The singularity isn't a place you could fly toward and avoid. It's a moment. It's your future. Like next Tuesday is your future. You can't choose not to arrive there because it isn't a destination. It's a date. Sound familiar? Our universe is expanding. Every galaxy is rushing away from every other galaxy in every direction all the time. There's no center. No edge you could point a telescope at and say, that's the boundary. And from any galaxy's point of view, the exact same thing appears to be happening to everyone else. That's also precisely what it would look like from inside a black hole if the inside were expanding instead of collapsing. No visible center, no visible edge, just expansion everywhere, forever. Because the edge was never out there in space. It's back there, in time. It's the Big Bang. And here's where it flips. If our Big Bang really is the far side of a black hole in some parent universe, then the singularity, the thing every black hole eventually creates, isn't waiting for us up ahead. It's the beginning. It already happened. We're living inside the explosion. That changes what the edge of the universe even means. We've spent decades searching for it out in space, looking for a wall, a boundary, a place where things stop. But if this model holds up, the edge was never out there. It was 13.8 billion years ago, behind us, sealed shut the instant we crossed it. We didn't fly past the edge of our universe. We were born inside one. And once you accept that, the rest cascades fast. If our universe formed inside a black hole, then every black hole inside our universe, and there are hundreds of millions of them in our galaxy alone, could be doing the exact same thing right now, each one collapsing toward its own bounce. Each one potentially inflating into its own universe, with its own stars, its own black holes, its own big bangs. Universes, inside universes, branching every single time a massive star runs out of fuel and caves in on itself. More black holes mean more bounces. More bounces mean more universes. More universes mean more stars, more black holes, more bounces again. The whole thing becomes a kind of cosmic family tree with no top and no bottom. Just an endless chain of explosions, each one looking, from the inside, like a beginning. And if Smolin's idea is right, the universe is best at making black holes. The ones with the right gravity, the right amount of matter, the right conditions for stars to live and die, are the ones that produce the most offspring, which means the laws of physics in our universe might not be an accident. They might be the result of billions of generations of cosmic selection, favoring exactly the kind of universe that's good at making more black holes, including ours. So think about what that means for you, right now, reading this. Every night, you look up and see stars that seem infinitely far away in a universe that looks infinitely open. But if this idea holds up, infinite was never the right word. You're sealed inside a boundary you can't see, can't touch, and can never cross. Not because it's too far away, but because it's in your past, and the past is the one direction nothing can travel back through. Somewhere out there, in some universe we'll never detect, there might be a black hole that gave birth to everything you've ever known. Every sunrise, every person you've ever loved, every thought you've ever had. And on the far side of every black hole inside our own universe, the same thing might be happening again, right now, to someone or something we will never meet. We spend our lives scanning the sky for the edge of everything. Maybe the wall was never ahead of us. Maybe you're already past it.